Hi, all of you. This is YVS from VS the Best channel. We are proud of saying that it is a unique channel to explain any concept from grassroots level. A student should understand from the grassroots level of the concept. Definitely, in every session, in the explanation of any concept, we go to the grassroots level. So every student should follow very much concentrating in the concept explanation, then they will be very strong. A student should be very strong in the theoretical part, definitely objective part he can do easily, those who are strong in the theoretical part. Simultaneously we are going to discuss both the theoretical and numerical and objective type also in every session. Now, what is the stereochemistry? Definitely we should talk about, because SN1 and SN2 mechanism we have observed already. The compounds are sometimes maybe optically active, optically inactive also. What is this optical concept? Even the compounds have same physical and most of the chemical properties are also same. They differ in one aspect. What is that aspect? That is relating to the optical isomerism. Whenever we have studied that plane polarized light, not ordinary light, it is a plane polarized light, in short we can say PPL. How do you produce this light? Our ordinary light, it propagates, this is the source of light, it propagates in all directions equally. It propagates in all directions equally. But when this light passed through the when this light passed through a nickel prism, it is a nickel prism. Passed nickel prism, only light is emerged with a single directed only. The light emerged with a single direction. All the rays, it is called PPL, plane polarized light. All other directions will be cut in this nickel prism. So this light is we call it plane polarized light. When PPL is passed through the solution, we have taken organic compound solution. A solution of organic compound, it is a solution of organic compound. When the PPL is passed through this organic compound, it may pass in the same direction, it may deviate in the clockwise direction, it may deviate in the anti-clockwise direction. So there are three different ways of deviation of the plane polarized light. If the plane polarized light, there is no any effect of this plane polarized light, then the compound is called optically inactive. We call it optically inactive compound. Simply OI, we call it OI, optically inactive. It means it is not able to deviate the PPL in any direction. If the compound moves, this plane polarized light, this compound moves to the clockwise direction, then the compound is optically active. I hope you have understood what is when do you say that the given compound is optically active. Optically active the compound is. Since it is moving clockwise direction, we call it dextro rotation. This is rotating the plane polarized light towards clockwise or rightwards. So we call it dextro type of the compound. It is angle. How much angle also we can calculate by using polarimeter. If you use polarimeter in this setup, then it gives how many degrees it is deviated also. So that is a represented angle. For example, deviated maybe 90 degrees or 85 degrees, like that. Plus, since it is a dextro, we represent with the plus. Dextro rotation. If it is anti-clockwise, it is called levo-rotatory, the compounds. So it is represented with a deconfiguration, or otherwise a plus with a degree, deconfiguration, or the D compound, dextro compound. Here, levo-rotatory means anti-clockwise. It is represented by small l or minus before the angle, before minus 70 degrees or any angle. So that is represented by. Yes, now this is called levo-rotatory compound, dextro-rotatory. If not any direction, we call it optically inactive. So compounds are based on this concept. There are three types of compounds. Fourth type also is there. Sometimes these two compounds are formed equally in 1:1 ratio. Then we call it racemic mixture. That compound is represented with DL symbol before the name of the compound, and or another method is plus and minus together. Dextro, it is both dextro 50-50%, 1:1 ratio of the compounds. This is optically active or optically inactive, deciding experimentally. This phenomenon is called optical isomerism. The compounds are called optical isomers. And another name you should know that both levo and dextro separately, these two compounds. For example, our hands, yes, our hands looking like alike only, but they are not superimposable. I will tell what is about this. First of all, we have understood that what is a dextro, what is levo. Okay, that is based on the polarized or deviation of the polarized light. We have decided whether the compound is a levo-rotatory or a dextro-rotatory. But what makes the compound this rotation? What is the changes? What are the changes in the structurally of the compound? That you should know. That means for that an organic compound should be what kind of it should have stereo center. It should be asymmetric carbon. The compound should have asymmetric carbon or chiral center. So these are the terms relating to the stereo or optical isomerism. Okay, let us talk about this. For example, 2-butanol, 2-propanol, let us take. And let us see that. So this is about optical isomerism. When does it, when it is called dextro or levo or not any optical inactive. Now let us go to the structural point of view. Structural point of view, which compounds exhibit this isomerism? Which compounds exhibit this isomerism structurally? Now, relating to the structural aspects of the compounds, yes, let us see. A compound should have asymmetric carbon. What type of carbon? Asymmetric carbon. Then only it exhibits optical isomerism. What is meant by asymmetric carbon? It is also called chiral carbon. Chiral carbon. A carbon compound which contains carbon with 4 different groups around it. Because it's a tetravalent. Carbon is a tetravalent. It can form 4 bonds. 4 different groups there should be. For example, what I say, 2-propanol. 2-propanol. Ol. One is OH group. Ol. Functional group is ol. 2-propanol. Second carbon atom. This is CH3. This is CH3. This is H. Okay. But these are same groups. This compound cannot exhibit Optical isomerism. This is optically inactive because only three groups are different. Fourth group is same. Methyl group. Two methyl groups. So it cannot exhibit. If you take two butanol, let us see. Two butanol. Two butanol. 2-butanol. What is the strain, open chain structure? Second carbon atom has OH group. Yes, CH2, CH3. Yes, this is 1, 2, 3. Butane. Second carbon has a OH group. So it is called 2-butanol. Take this carbon. It is the chiral carbon or asymmetric carbon, because this carbon atom has a one hydrogen atom, one CH3, another one C2H5, C2H5, and one more is OH. This is the structure of 2-butanol. Yes, definitely this compound exhibits optical isomerism, because this carbon is a asymmetric carbon. It contains 4 different groups around it. So this is the first and foremost requirement for any compound to exhibit optical isomerism. Yes, 2-butanol exhibits optical isomerism, because what is the other thing we have? It has mirror image. It has, what is the mirror image of OH group comes here, and carbon here, upside hydrogen, and this side that side CH3, and downwards C2H5, ethyl group, methyl group, hydroxyl group, and hydrogen. 4 different. So these two compounds are looking like mirror images. So these two, one is a D form, another is a L form, dextro and levo. If this compound rotates a PPL towards clockwise, this compound definitely rotates the compound in the anti-clockwise, means L form it is. Dextro from L form, means this is represent plus, this is represented by minus symbol before the name of the compound. Before the name of, so here left side 2-butanol is called plus 2-butanol. How do you represent? Plus 2-butanol. This is minus 2-butanol. That is the importance of this rotation, and writing the name of the compound by using this rotation, type of the rotation. So this is about optical isomerism. One more important property of these two compounds, D and L forms. What is the nature? They are not superimposable. See, our hand is center of our hand is some carbon atom. 4 different groups are there. For example, otherwise no need of taking carbon, just our hand. These are looking like mirror images. These are not superimposable. Superimposable means every finger should come onto the other finger, similar finger, but not coming. Here, left, this hand, small finger comes onto the thumb. So whenever the fingers are not matching the respective positions, then we say that word non-superimposable. Non-superimposable compounds exhibit optical isomerism. That is. So we cannot say that these are like keeping your hands like this superimposed. No. As it is, we have to bring keep the one hand on the other hand. Then they are not coinciding, the fingers. So non-superimposable compounds also. If we then bring this compound like this, non-superimposable, because OH comes to the right side, here OH is on the left side. So we say non-superimposable. So what is the second requirement? Non-superimposability also gives the optically active nature of the compound. So this is to some extent the optical isomerism. I hope you have understood. Otherwise, you message me. I have written already my number given, and message me, and subscribe the channel, and comments on this session also. I hope you will share it also. Thank you all.